Okay, hello students, welcome to Friday Math Happy Hour. Today I am going to cover simple and compound interest annuities and systems of linear equations. I believe this is chapter 5 and chapter 6 from Math 1324. So these are all the topics that I need to cover for today. I know this is a lot of material, but since this is like a summer one mini master, I have to cram like 16 weeks into a 5-week course. Okay, so that's why I just got a few examples of each section. So hopefully we'll be able to finish. So to start, let's start out with simple interest. Okay, simple interest. This is a formula, guys, for simple interest. The simple interest, the INT stands for interest, the PV stands for present value, and the R stands for interest rate, and the T stands for time. The interest is a fee paid to use someone else's money. The PV is a present value or principal. The R is the interest rate, and it has a percent symbol. And the T is time in years. Okay. Okay, now there's two formulas for this section here. I believe this is section 5.1. There's two formulas that you can use. Okay, so for example, if you have, once you have the interest, the future value is equal to the present value plus the interest. Okay, now I'm going to derive the other formula from this formula here. Okay, what was the interest? The interest was PV RT. Okay, now I'm going to factor out the PV, which is a present value, right? That's what they have in common. So I factor it out. So what's left? 1 plus RT. So this is the other formula that's being used in this section. So every time the question is asking for simple interest, we're going to be using either one of these two of those formulas. Okay? And for this formula, the FV stands for the sum of the principal and the interest earned, which is the future value, same thing. This will be the present value or principal. The R is the interest rate and percent, and the T is time in years. So you need to know that if the months are given on the word problem, then it's going to be the given months divided by 12, because the time has to be in years. And since there's 12 months in a year, you're going to divide the given months over 12 if the time is given in months. And also the interest rate must be in a decimal. So you're going to drop the symbol and move the decimal place 2 places to the left. Okay, let me show you an example. Example of 5% is equal to 0.05. Okay, because the formula will not take the 5%. You have to convert it to a decimal. Okay, so let's do an example. Here we go. Example 1. Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle, and how much interest did Martha pay? So, solution, which formula should we use? Right, from the previous slide. Can we use that one? We can use that one, or we can use the other one, right? So these two, they go hand in hand. So I'm going to do this example using both formulas. Okay, just so you know, because at times students are confused. They say, teacher, what formula should I use? So I'm going to show you that it doesn't matter what you use. Okay, you can use either or. So for example, okay, does it matter? It's going to be no. For example, say we're going to use this one here, okay, the interest equals to the present value times R times T. So if we're going to use this one, right, and we're trying to find the future value, then we're going to have to use this one accompanied with the interest rate formula. The future value, which means all the money that you paid back, will be the present value of what you borrowed plus the interest. Okay, so here we go. So on this word problem, right? So what's given? Martha borrowed 12,000. So how much money did Martha borrow? 12,000. That's the present value. The interest rate is going to be in percent, will be 3.5%, which will be 0.035, right? Because you have to convert it to a decimal. And the time is in years, so 5 years. So students need to know how to extract the information from the word problem into the specific, where it belongs. On each variable represents something, right? So then Let's put into the calculator. So if you put that into the calculator, it's going to give you 2,100. So that's how much interest Martha paid. But also, they're also find the total amount that Martha paid. So this is the answer for the second part, how much interest did Martha pay, which is 2,100. Okay, so to find how much did she pay total, we have to use the other formula, which would be the present value. The present value was 12,000 plus the interest, which was 2,100. So total she paid 14,100. Okay, so total Martha paid is 14,100. What was the interest? 2,100. So this is how you do these type of problems. Okay, let's do the very same problem, but instead of using the first formula, which was INT equals to PVRT, we're going to be using this formula here, which is future value equals to present value, parentheses 1 plus interest rate times time. So again, what are we looking for? Right, we're looking for the future value. So the 12,000 was the present value. The interest is 3.5%, which will be 0.035. The time will be 5 years, 5. So let's plug him into the formula. Right, there's my present value. It's going to be 1 plus 0.035 times 5. And we all put this into the calculator. So it should give us 14,100. So that's how much Martha paid. That's how the total amount that Martha paid. So then how much interest did Martha pay? So then we have to use this formula accompanied with the formula that we just used. The interest is equal to the future value minus the present value. So the future value is 14,100 and the present value is the 12,000. So what was the interest that Martha paid? Is $2,100. You see, students, so it doesn't really matter which one you use. But both formulas are accompanied by another one. For example, this one here is accompanied by the interest is equal to future value minus present value. And in the other slide, I believe the future value was the present value plus the interest. Okay. Okay, now, example number 2. Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25 simple interest to have enough to pay the tuition bill? So solution. So this is a formula that we're going to be using. Okay, because on this one, she needs to pay a tuition bill of $7,000, right? So this is what she needs to pay in the future, right? So we're looking for the present value, right? So this is how much she needs to pay in 10 months, which is $7,500. What's the interest rate? The interest rate is 1.25%, which will be equivalent to 0.0125. The time is 10 months. So remember, guys, we cannot put 10 here, guys. It's got to be 10 divided by 12, right? Because remember, on the first slide, it was a given month by 12. So this is my time. So now let's plug everything into the calculator. But eventually, the book and also my math lab, this is a formula to find the present value. Okay, and right now, let's do it this way, and I'm going to show you another way to find the answer. So future value is 7,500. My interest rate is 0.0125 times 10 over 12. So this should give you, the answer will be $7,422.68 because you run down to your nearest penny. Okay, now, here's another way without clearing the calculator, right? So I always show my students both ways, and they can decide which way to use. Okay, now this way, we don't need this present value formula. We're going to find for the present value right here with this formula here. So this is how we do it. Okay, we're going to enter it, right? There's my future value, which was a 7,500. There's my interest rate, which was 0.0125, and my time was 10 over 12. So I'm going to enter this in the calculator, right? This is what I'm going to enter in the calculator. I'm going to put 1 plus 0.0125 times 10 divided by 12, and this is what it should give you. 1.01041667. Then I'm going to hit the inverse key. The inverse key actually it multiplies both sides by the inverse here, right? So you're going to put the inverse key, you're going to press there, then you're going to enter. When you press on the inverse key, this is what you should see, answer to the -1, and then you enter 7,500, and you can enter it, and that's your answer. See, we get the same answer. Okay, so you guys have 2 ways to do it, I believe. And in the future slides, I'll be using this formula here. I'll be using this concept here. Okay. Okay, now simple interest continues. Example number 3. John received $10,000 loan from his aunt to buy a car. His aunt charged him 2.5% interest. How long was the term of the loan if the interest accrued was 125? Okay, so here we're looking for time, right? How long was the loan? So which one should we use? Okay, so this was the interest, right? So which one should we use? So I'm going to stick with this one here because this is the interest accrued, which is the INT. So the INT, okay, we're looking for the time, right? How long means time. So the INT or the interest is 125. This is a present value. The interest will be 125. This is 125, right? The present value will be the 10,000, and the interest rate will be the 2.5%, which will be 0.025. Let's plug him in. So here, right, if we multiply 10,000 by 0.025, it's going to give us 250. Now we divide both sides by 250, and this is what it should give us. Should be 1/2 or 0.5. So the answer will be half a year, right, or 0.5 years. Okay, now this the next slide was going to cover 5.2, which is another formula called the compound interest formula. For this formula, right, this is a formula that we're going to be using, or FV equals to PV 1 plus I. These two formulas are the same one. The only difference is that here we have R divided by M, and here we have I. So I equals to R divided by M, and my N equals to M times T. And here what everything stands for. AV stands for the future or maturity value. PV stands for the principal or present value. The R stands for the interest rate per period covered to decimal in a decimal. The M stands for number of compounding periods per year. T stands for the number of years. The I stands for the interest rate per period, which is the R divided by M. And the N stands for the total number of compound periods, which is the M times T. Okay, now, so these are key words for compound interest problems. Here are the key words, and here's what the M stands for. For example, if they say yearly or annually, then M is equal to 1. Bi-yearly or semi-annually, M is equal to 2. Quarterly, M is equal to 4. Monthly, M is equal to 12. Weekly, M is equal to 52. Daily, M is equal to 365 or 360. Many times the book will mention to use 360. But if they don't state what to use, you're going to use 365 because there's 365 days in a year. If it says compounded continuous, then you have a different formula. Then this is a formula that we're going to be using, which is the future value equals to the present value, e to the power of RT. Okay, now, compound interest can be, okay, this is the usual compound interest. Compound interest can be used to invest a certain amount of money without depositing additional money. So in other words, say you have some money there at your house. Say you have about 10,000. You can actually invest it, right? Invest it at a bank, and you don't have to put no more money in there, and you can invest it for a year or 2 or 3. It depends on the bank, on how many years, or maybe it depends also on you, how many years you want to have it there, and then you're going to be getting interest. So you're going to be getting extra money on top of the money that you're going to that you're going to invest. Example. Okay, here we go. You deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much will you be in your account after 5 years, and how much interest did you earn? Okay, so there's my formula. So I like to use this one better because it'll be easier for the calculator. The future value equals to present value, 1 plus I to the nth power. Okay? So there's always 7 things that you gotta find: the future value, present value, the interest rate, the M, compounded, the T, the I, and the N. So let's extract the information from the word problem. Okay, what are we looking for? How much interest did you earn, right? So we're looking for the future value. It says how much money will be in your account after 5 years and how much interest did you earn. So we're going to be looking for the future value. So the 1,000 will be your present value. The 6% will be your interest rate. Converted to a decimal, it's going to be 0.06. The number of times it's compounded is compounded quarterly, so M is equal to 4. And T is 5. So I is equal to R divided by M, right? My R is 0.06 divided by 4 is going to give you 0.015. And my N is M times T, so it's going to be 4 times 5 is equal to 20. So all we do is plug everything into the calculator, right? There's my present values, 1,000. My I is 0.015, and my N is 20. Right, so all you do is put in the calculator, and this is what you get. Round it out to 2 places. It's going to be $1,346.86. Okay, so after 5 years, there will be $1,346.86 in the account. Okay, now how much interest did you earn? So the interest will be the future value minus the present value. So it's going to be $1,346.86 minus the $1,000 that you actually put in there. So it's going to give you $346.86. So that's how much interest that you earned. Okay, let's move on. Continuous compound interest. So this is the continuous, which is a different formula. Okay, you deposit $1,000 in an account at your bank that pays 6% compounded continuously. How much interest will be in your account after 5 years? So again, so this is a different formula, right? Because this is continuous, so that's the formula for continuous. So we're looking for the future value. So my present value will be 1,000. My interest rate will be 6%, which will be 0.06. My time will be 5 years. So let's plug everything in. Right, we can put it straight into the calculator. So here, guys, you got to be careful with 0.06 times 5. To be safe, input the parentheses, guys, because there's some calculators that will not say that you put 0.06 times 5. There's some calculators that they will put the 0.06 and then times 5 on the bottom. Okay, so that will be wrong. The answer will be wrong. So to play it safe, every time you have an exponent, you always put parentheses, right? For example, it'll be parentheses 0.06 times 5 close parentheses. So now it can be input into the calculator. So this is what the answer should be: $1,349.86. You see, guys, same thing as the other one, as the other formula. As the other one, but it was a different formula. But it was, I believe, everything was the same, except for the compounded continuously, and the other one was compounded quarterly. So after 5 years, there will be $1,249.86. So how much interest did you earn? And again, it's going to be the interest earned will be the future value minus the present value. So it'll be 1,349.86 minus the 1,000. So there's the solution for this problem here for the interest earned, which will be $349.86. Let's move on. Compound interest. Okay, continues. Here we go. This is example number 6. I want to be earning an annual salary of 100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase of 4% per year, and the starting salary is negotiable. What salary should I request in order to meet my goal? Okay, so let's find out. There's your formula, right? There's the alternative formula, which is, I believe, is better. Okay, so here, I want to be earning an annual salary of 100,000, right? So isn't that the future? So we're looking for the present value. So the 100,000 will be in the future, right? That's how much I want to be earning in 15 years. The interest rate will be 4%. So it'll be 0.04. Compounded, let's see here, compounded annually, right? Job that guarantees the annual salary, so it's going to be 1. The time is going to be 15. My I, which is R divided by M, will be 0.04 divided by 1, will just be 0.04. And the N is M times T, which is 1 times 15, will just be 15. So what we do is we're going to plug into the calculator. So 1 plus 0.04 to the 15th power will give you 1.800943506. Then we divide both sides by 1.800943506. And this is what we should get. It should be 55,526 and 45 cents. Okay, now here's the other way that I'm going to show you. Okay. So I'm going to enter this into the calculator. The parentheses was 0.04 plus parentheses to the 15th power. See, there it is. So after you do that, this is what you should see in the calculator, right? That was the answer. Then you're going to hit the inverse key, right? Because I want to multiply both sides, right, by the inverse of what I got here, which is 1.809433506. Press the inverse key. Then you should, once you press the inverse key, this is what you should see on your screen. There you enter 100,000, and that's the answer right there. You see, we get the same answer. I always show this formula because a lot of students, they actually know how to extract the information, but they have a hard time plugging in the values into the calculator. So that's why I show this step by step, so students can actually follow it this way. This is the one that the book uses, and also the one has that. Okay. Okay, now we're doing future value of an ordinary annuity. I believe this is section 5.3. And this is a formula, right? Different formula. And remember, the R divided by M is going to be my I. My M times T is going to be my N. Same thing as before. Okay, so this is what everything is. Okay, how do we use these like in the real world? Future value ordinary annuities can be used to accumulate funds for some time in the future. You must set regular deposits during the specific time. But regular deposits means regular and the same amount of money. Okay? So for example, let's say you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. So you're going to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of those 20 years? Okay. And also, let's say you are planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly on the rise, you want to make sure that you have enough money in 18 years for your child to attend college. This is like an actual scenario, guys. For example, if you guys are in school now, right? You're in school to make a better living, and to make a better living means that if you're getting financial aid, more likely once you graduate and you have your job, you're not gonna make. You're not gonna qualify for financial aid no more, right? Because that's what you're in school for, to make good money. So your kids, when you have kids, more likely they're not gonna be able to receive financial aid. So it's always wise to begin setting up an account for a certain amount of time. So when your kids turns 18, they'll be able to have enough money to attend college. That's why I like to use like real life examples. Okay, so let's see here. This is example number 7, the one that I explained earlier. Okay, say you can afford to save $1,000 every month and you want to set up an annuity to make interest on the account. An investment company offers 3% interest for 20 years if you deposit $1,000 at the end of every month. How much money will you have in 20 years and how much interest will you earn? Okay, so let's put the formula down. Let's put all the variables, right? So here, what are we looking for? We're looking for how much money will you have in 20 years. So we're looking for the future value. So the payments will be $1,000 per month. The interest rate is going to be 3%. So it'll be 0.03. Compounded, let's see how many compounded you can afford every month. Oh, every month, so M is going to be 12, right? So it's monthly, so it's 12. My time is 20. My I is R, 0.03 divided by 12, which will be 0.0025. My N will be M times T, so M is 12 and T is 20, right? So that'll be what, 240? So all we do is we already extracted the info. So let's put everything into the calculator. Okay. So again, if you do this first, right, the numerator, that's what it will give you. Then if you apply this in parentheses, it's going to give you 328.319981. You multiply by 1,000, so you're going to get $228,301.99. Round it off, will be 302 because 99 with an 8 here, that rounds off to 1. So you're going to add a 1 to the 1 here, so it'll be 302. Okay, now, so I'm going to show you how to do it in the calculator with one steady flow. So first, that's what you enter in your calculator, right, which is the numerator here. Once you enter it, this is what you should see, right? That's the answer. Then without leaving your calculator, you can go in a steady flow and reach the answer. So now you're going to hit divided by, right, the division key. And this is what you should see on your screen. Answer divided by, right? So it's going to be this answer divided by, then we're going to put 0.0025. You're going to enter. So this is what you get. This is what you should be on your screen, on the calculator screen. Then you're going to multiply that by 1,000. You press the times key. You should see that on your screen. You enter 1,000 because you multiply by 1,000, and there's a result. Round it out to your nearest penny. So it's going to be $328,302. Hey guys, isn't that amazing that if you can save that much money in a month, in 20 years you have 328,000? So then how much interest did you earn? Okay. So there was 240 payment, right? Because you made 240 payments times 1,000. So that's going to give you 240,000, right? So we subtracted 240,000 from the total, from the future value, which was 328. So you made $88,302. That's what you got in interest. So you earned that money, that extra money, because they were paying you interest. Here's example number 8. Here's the one that you're trying to send your just born child to college. You are planning on sending your just born child to college when she turns 18. You want to have $250,000 in the account for tuition in 18 years. How much money would you deposit at the end of each quarter in an account paying 5% compounded quarterly? Okay, so here we go. There's your formula. So let's put everything in there. So now, right, we're looking for how much money should we put in right now. So we're looking for the payment. You want $250,000 in 18 years. The interest rate they offer was 5%. It will be 0.05. Compounded quarterly, M is equal to 4. And the time will be 18. So R divided by M will be 0.05 divided by 4, which will give you 0.0125. And the M times T will be 4 times 18, which will give you 72. So again, let's plug everything into the calculator. Right, so everything is plugged in. So first, I'm going to do the numerator, write it how it is, right? Just how it is. Then you should see that in the calculator after you enter it. Then you're going to press the division, right? So division. Then you should see that on the screen, the answer divided by. Then you're going to enter 0.0125. Once you enter that, this is what you should see on your screen. 115.6736215. Then you're going to hit the inverse key. You're going to press on the inverse key. That's what you should see on your screen, the answer to a -1. That means the inverse. Then you're going to enter the 250,000. So this is what you should see on your screen. So the payments will be $2,161.25. That's how much you need to deposit every 4 months because it's quarterly. So this is extra information. How much money did you earn in interest? So first, how much money did you put into the account? So there were 72 payments. You multiply it by the actual payments, right? So it was 155,610. So the rest of the money to reach the 250 was in interest. That's how much money you earned in interest. So we're going to subtract 250,000 minus 155,610, which you got $94,390 in interest. That's how much money you got extra. Okay, which is not bad at all. Okay. Now, this is the present value of an annuity. Now, this is another formula. This is from section 5.4. Okay, so again, this is a formula. This is the alternative formula on the right. And this is used, most common use of present value ordinary annuity are for purchasing an expensive item, such as a vehicle or a house at the present time and making equal payments. Okay? So let's do an example. For example, you want to purchase a car. What are your monthly payments and how much will you end up paying? You want to get an idea on the process of purchasing a house. Okay? Key factors to purchase a house or an expensive item. You must have a job, right? You must also have good credit. The higher your credit score, the lower interest rate you will get, which will be better when purchasing a house or an expensive item. You have to get pre-qualified for the maximum amount of a loan. So before you want to buy a house, guys, it's always, well, you have to have a job. With no job, you cannot purchase a house unless you have that much money cash in the bank. So before you get a house, you have to have a job, you have to have good credit, and also it's always wise to get pre-qualified because this way you will not be wasting time and looking at houses that you can afford. Okay? So now, let's do example number 9, and then we'll do example 10 on purchasing a home. So for example number 9, says you buy a new car that costs $26,750. What are the monthly payments if the interest rate is 4.2% and the loan is for 5 years? And how much interest did you pay? Okay, so let's put out the formula. So remember I said, guys, there were 7 things. You see there's 1, 2, 3, 4, 5, 6, 7. So let's see what we're looking for. We're looking for the monthly payment, right? So we're looking for the payments. So the present value, how much money you want to borrow from the bank, will be $26,750. The interest rate will be 4.2%. So it's going to be 0.042. Compounded, how many monthly payments? So it's going to be M is equal to 12. Most of the time, guys, with vehicles and with houses, it's going to be M will be 12, right? Because you're giving monthly payments. That time will be 5 years. So the I will be R divided by M, so it will be 0.042 divided by 12 will be 0.0035. And the N is M times T, so it will be 12 times 5 will give you 60. So let's put in the formula. Okay. And again, guys, check this out, guys. When you're solving for the payment, right, which is here, right, you got the amount over here, the future value, and or the present value. You got the payment. So this is the key that you got to use the inverse. Okay, if you do it this way. So first, I'm going to do the numerator, the 1 minus parentheses 1 plus 0.035 to a negative 60. So you can enter that in the calculator. So you should see that. That's what you get when you put the numerator into the calculator. Then you're going to put division because you're going to be dividing, right? And that's what you should see on the calculator. On the calculator, then you're going to enter 0.0035. Once you do that, this is what you should see on the screen. So I know that this right side will be 54.003385802. Now I'm going to hit the inverse key. Okay? Then that's what you should see on your screen. Then you're going to enter the 26,750. This is what you should see on your screen. It's going to be 495.05, so it's going to be $495.06. That's how much your monthly payments are going to be. Okay, now how much extra money did you end up paying, right? The extra money is money and interest. So let's find out. So we're going to multiply the payments, right? The payments times 60, right? Because there's 60 payments. So you multiply those out, you end up paying $29,703.60. So let's find out how much interest did you actually pay, right? That's how much you paid for the car. So we subtract the future value minus the present value to get the interest. So you end up paying $2,953.60 extra. So that's how much extra money you paid. Okay. Now here comes what a lot of students like to hear. I mean, most of the times when I teach this course, students they like to hear or they like to find out or find more information on how to purchase a home. Okay. So this is example number 10. You want to purchase a $325,000 house with a 30-year fixed rate at 3.9%. The monthly payments and how much interest did you end up paying? Okay, let's find out. So there's my formula. Let's extract the info. So we're looking for the payments, right? So this is what you're going to borrow from the bank, which is a present value. You're going to borrow this from the bank. That's $325,000. The R is the one with a percent symbol, which is 3.9%. Converted to a decimal will give us 0.039. The M, right? The M will be monthly, right? Monthly payments. So it's going to be 12. That time will be for 30 years. So the I will be the R, 0.039 divided by 12, which will give us 0.00325. And the N will be N times T, which will be 12 times 30, which will be 360. So let's plug everything into the calculator. And again, we first start here with the numerator, right? So we enter that. That's my result, 0.6890436,901. We divide that. We divide it by 0.00325. So we get 212.0134431. We're going to hit the inverse key, right? So when we hit the inverse key, that's what you see, and then we're going to enter that 325,000. So this is the answer that we get, 1,532.921664. Rounded out to a nearest penny will give us 1,532.92. So that's how much your monthly payments will be. So how much money did you end up paying for the house? Right? End up paying for the house. We know it was worth $325,000, right? That's how much you purchased. But let's find out how much extra money you paid. So we're going to multiply that 360 times 1,532.92 cents. So you end up paying $551,851.20. That's a lot of money, right? That you end up paying. So now, how much interest, how much extra money did you pay? So we're going to subtract, right, the house value minus the future value. So you end up paying $226,851.20 extra, which is a little bit over $250,000 extra. Isn't that amazing, guys? So, but you can actually pay it in this time. For example, if you put money into the principal every month, you're going to save a lot of money and you can pay it off in less time. For example, when we got our house, I use these type of formulas to actually pay the house in 10 years. So math is crucial, especially for these type of problems, because these apply to real life situations, and you can actually save a lot of money by applying some of the math that you learn in this course. Okay. So now we're gonna do, well, that's how much you paid, right? The interest. So now we're gonna move on to solving systems of equations with two variables. Okay. So solving systems, this is chapter 6.1. You can solve systems by graphing. By graphing, right? Let's call it equation 1. So we have to graph both equations. So we know that my slope is equal to 3, right? So it'll be 3 over 1. That's my slope, my m. My b is my starting point, and this is my y-intercept point, 0, -6. So to graph it, right, this is my starting point, 0, -6. So it's going to start right here at the bottom, 0, -6. Then I'm going to go up, right, because this is a rise over run, so I'm going to go up 3 and across 1. Let's see, 1, 2, 3, and 1 to the right, so that should be my next point. And all we do is draw a line through those 2 points. Now, let's do equation number 2. Equation number 2 is not in slope-intercept form, so I have to rewrite it in this form. So I'm going to add 5x to both sides. Then I'm going to divide both sides by -2. So this is my result. Now my slope is -5/2. And my b is 5, so that's my starting point will be 0, 5, which will be my y-intercept. So we start at 0, 5. 1, 2, 3, 4, 5. So we start there. We're going to go down. This means we're going to go down 5, down, and 2 to the right. So 1, 2, 3, 4, 5, and 2 to the right. So we draw a line across those 2 points. So where they intersect is the solution. So the solution will be 2, 0. That's the solution to this problem here. Okay, now there's different methods of solving this type of systems. For example, I just showed you by graphing. The next slide will be a substitution, and then also the addition method. So let's go to the next slide. If you notice, we have the very same problem, right? But now we're going to solve it another way, which is by substitution. So let's call this equation 1 and equation 2. But okay, here's the solution. You're trying to find which one you're going to plug into the other equation. So you're always trying to find one of the variables that's isolated or by itself. For example, in this case, equation number 1, the y is already isolated. So my y is equal to 3x minus 6. So I'm going to go to the next equation, which is equation 2, and I'm going to plug in 3x minus 6 for the y. Okay. So I'm going to plug in right here for the y will be the 3x minus 6. Then I distribute. That's going to give us negative 5x minus 6x plus 12 equals negative 10. So I'm going to combine like terms. So negative x minus 6, it will give us negative 11x plus 12 equals negative 10. Then to solve for x, I'm going to have to subtract 12 from both sides. Right, so this will give us negative 11x equals to negative 22. Then we divide both sides by negative 11. So my result will be x equals 2. Now, you have to find the y value. So you have to go back to either equation 1 or equation 2, whatever is easier for you. In my opinion, since equation 1 is already isolated, it's wiser to go into equation 1, to use equation 1. So I'm going to plug in 2 for x, right? So I'm going to plug it in here. So it's going to be 3 times 2 minus 6. So it'll be 6 minus 6. So y is equal to 0. So x is 2 and y is 0. So there's my solution, 2, 0. You see, same thing as the other one. Okay. Now, let me go back here. Now, let's work it another way by using the elimination method. And if you notice, it's the same problem, okay? I just want to show you that there's different ways to solve systems of equations. So now this is another method. It's called the elimination method, or it's also known as the addition method. Okay. So to use this method, both equations must be in the form of ax plus by equals c. If we notice, equation 1 is not in that form. So I need to rewrite equation 1 in proper form. Okay. So I'm going to subtract 3x from both sides. You see, now it's in proper form. So we got equation 1, equation 2. So here, guys, you have to eliminate the x's or eliminate the y's, whatever is easier for you. Okay, in my opinion, here I'm going to get rid of the y's, right? Because if we multiply the equation 1 by 2, you see 2 times y will give us 2y. Then when added to negative 2y, it's going to be eliminated. Let me show you. So 2 times negative 3x will give us negative 6. 2 times positive y will give us 2y. And 2 times negative 6 will give us negative 12. Equation 2, we just bring it over, right? And then we add them. Negative 6 minus 5 will give us negative 11x. And the y's will be eliminated. And negative 12 minus 10 will give us negative 22. Then we divide both sides by negative 11. So we have x equals 2. Now we go back, like before, to either equation and plug in x equals 2 to either equation 1 or 2 and solve for y. And again, my opinion, it'll be easier to plug it into equation 1. So I'm going to plug in the 2 there. So y equals to 0. So my solution will be, again, 2, 0. Okay. Okay, now I'm going to work the very same problem again, but now instead of eliminating the y's, I'm going to eliminate the x's. Just so you know, it's the same thing. Okay, we get the same values. Okay, that's what we did in the previous slide. So the equation 1 must be in proper form. Right? So here's the difference from the last slide. On the last slide, previous slide, we eliminated the y's. But look, if we want to eliminate the x's, we need to multiply the first equation by negative 5 and the second equation by 3. Because negative 5 times negative 3 will give us negative 15. And the second equation, I need to multiply it by 3. Because 3 times negative 5 will give us negative 15. And if you notice, but I need to multiply the negative 5 times every term in equation 1. In a similar manner, I need to multiply 3 times every term in equation 2. So this is what we get. If you notice, it's a little bit more work than the previous slide. But anyway, we should still get the same result. So the x's will cancel, right? They'll be eliminated. Here we have negative 11y equals to 0. We divide both sides by negative 11. So y equals 0. Then we need to go back to either equation 1 or 2 and plug in 0 for y and solve for x. So I believe here, guys, I'm going to go to equation 2. So y is 0, so I'm going to plug in the 0 where the y is. So this gives us negative 5x equals to negative 10. We divide both sides by negative 5, and our result will be x equals 2. So we got 2, 0. So that's my solution. At times, I believe your instructors on the exams are going to ask you to solve it in a specific way, right? Either by graphing, substitution, or the addition method. You have to use the proper form, even though you might get the right answer. But if you don't use the proper or the form being asked, it's wrong because you didn't follow instructions. So please know how to solve linear systems of equations in all three different ways. Okay. Okay. Now, how are these problems? What happens when you get something like 0 equals to 0 or 0 equals to a number? Okay, there's one that's called infinite solutions and one that's called no solution. Okay, for example, number 14. Here, guys, let's say I want to get rid of the x's. So I'm going to multiply, right, equation 1 by -2, because -2 times 3 will give us -6, and -6 plus 6 will be eliminated. But I need to multiply -2 times every term, right? And then equation 2, we'll just bring it over. If you notice, guys, right, everything canceled. 0 equals to 0, so what happens here? I guess when you have this situation, it just means that you have infinite solutions. That means you can have infinite solutions, not only one solution. Okay? Now, what happens when you get something like 0 equals to a number? Okay, like for example, this situation here. So again, I'm going to multiply equation 1 by -3. So -3 times 2 will give us -6x, -3 times 5 will give us -15, and -3 times 8 will give us -24. You see, if we add them, we get 0 equals to -6. This is not true. That's why it's going to be no solution. That means these lines are parallel. They will never intersect. Okay. Okay, now how do we use these type of problems in a real life situation? Well, here's an example. It says here, a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? So what's my solution? My solution is I need to find two equations. Okay? Here's how I like to explain these type of problems. So I'm going to use seats with seats and money with money. What does that mean? It means that, right, there's $8 seats and $5 seats. So I'm going to let X be adults and Y equals to children. So X amount of adult seats plus Y amount of children seats equals to 200 total seats. So it's going to be X plus Y equals to 200. Now here comes the money with money. So if adult tickets, right, are $8 and adult X represent adult, so this is going to be 8X. In a similar manner, children's tickets are $5 and the children's seats, right, is represented by Y, so this is going to give us 5Y. And what was the total money? What was the total revenue? It was $1,435. So my total income is $1,435. So there's my second equation. 8X plus 5Y equals to 1,435. So those are my two equations. Okay? Okay, now these type of equations are easier. You can solve it by graphing, which I don't recommend. You can solve it by substitution. Well, that's more doable. But the method that I will use is the elimination method because it's much easier because both equations are already in that proper form. So here, what should we get rid of? The x's or the y's? In my opinion, it doesn't really matter. So I'm going to get rid of the x's. So I need to multiply equation 1 by -8. So -8 times x will give us -8x. -8 times y will give us -8y. And -8 times 200 will give us -1600. And equation 2, we just start it over. So you see, guys, the x's were eliminated. So we get -3y equals to -165. So we divide both sides by -3. So y equals to 55. Now we go back. We need to find the x value. So I'm going to plug in 55 for y on either equation, on either equations 1 or 2, whatever is easier for you. So I believe equation 1 is easier because the coefficients are much smaller. So y is 55. So I'm going to plug in 55 for y there. Then we're going to subtract 55 from both sides. So y equals to 1, x equals to 145. So x equals to 145, y equals to 55, but the x represents adult tickets, and the y represents children's tickets. So there were 145 adults in the theater and 55 children. Okay. Now this is larger systems of equations. So these are larger, means that this is going to be three equations with three variables. Okay. So again, let's call it equation 1, equation 2, equation 3. So it's always wise, right? You want to have on equation 1 with a coefficient of 1 for the x. So if you can, always rewrite it, right? So here all we did was switch rows 1 and 2. Okay, there's a reason behind it, which I'm going to explain right now. Okay, but what's the plan? How are we gonna solve for x, y, and z? Okay, here's the plan. I'm going to get equation 1 and 2 and equation 1 and 3, and I'm going to get rid of the x's, eliminate the x value, the x variable. Then from here comes a new equation 2, and from the other one comes a new equation 3. Then I'm going to get new equation 2 and new equation 3, and I'm going to eliminate the y's. Once we do that, we're going to get something like z equals to something like c, where c is a real number. In other words, z equals to a number. Then we're going to, after all the steps, it should look something like this, guys, right? You see, that was my first equation. My second one came from either one of these two. It's going to come from either one of these two. And my last one came from here. But let me show you how we got this, okay? After you do all the steps, it should be something like this. So this is what we're going to focus to get this right here. Then we're going to back substitute. Okay, here we go. So we're going to get equation 1 and 2, right? We're going to get rid of the x's. So I'm going to multiply -2 times equation 1. This is why, guys, because it'll be easier to get rid of the x's if we have a 1 here as a coefficient. So -2 times every term in equation 1 will give us -2x plus 6y minus 4z equals to 0. Equation 2, we'll just start it over. You see, guys, the x's were eliminated. So this is my new equation 2. Now I'll repeat the process for equations 1 and 3. Right? And I'm going to get rid of the x's, so I'm going to multiply equation 1 by -3. So after I multiply -3 times every term in equation 1, this is my result. So equation 3, all we do is slide it over, and the x's will be eliminated. So this is my new equation 3. Now, how do we find, right, so now we're going to get the new equation 2 and the new equation 3, and we're going to get rid of the y's. So then, here, guys, you multiply by the least common multiple, which is 20, right? But at times, students don't know what the least common multiple is. So I just tell my students, you're going to multiply, right, they're both positive. So you're going to multiply, say, equation 1 by a negative number and equation 2 by a positive number. Because you want to have different signs on both, but the same number for them to be eliminated. So in other words, I'm going to multiply equation 1 by -10 and equation 2 by 4. So -10 times every term in equation 2 will result in -40y plus 30z equals to -30. And 4 times every term in equation 3 will give us 40y minus 28z equals to 28. Right? After we do the operation, it should give us 2z equals to -2, and we can divide both sides by 2 to give us the value for z, which is -1. Now, you see, guys, there's the setup that we mentioned earlier. You see, this is equation 1. Equation 2 was this one here, or also you can also put equation 3 here, guys, if you want, the new equation 3. But in my opinion, it's wiser to just keep the one with the coefficients that have smaller coefficients, which will be equation 2. And lastly, this is equation 3, which is z equals to 1, -1. So then we're going to back substitute. Okay, I know that z equals to -1, so I'm going to go to equation 2. I'm going to plug in -1 for z and actually solve for y. Subtract 3 to both sides. So for y equals 0, so y equals to 0 because we divide by 4, so y equals 0. Now I have y and z, so I'm going to plug in both values on equation 1 and solve for x. So y is 0 and z is -1. This will give us x minus 2 equals 0. We add 2 to both sides. So that's my solution. So my solution is x equals 2, y equals 0, and z equals to -1. Okay, now, how do we apply this in a real life situation here, guys? I'm almost done. I need, I think, this one, the setup, and work it out, and we're done. Here's how it's done. Tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were a total of 770 people at the concert, and the total ticket receipts were $1,150, and 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended the concert? Okay, what's my strategy? So I need to find 3 equations. 2 of the equations will be very simple. The last equation will be a little bit more challenging, okay? But let's take it step by step. So I'm going to do people with people and money with money. Here we have adults, right? So we're going to let x equals to adults, y be the teenagers, and z be the preteens. There's a total of 170 people, so it's going to be x plus y plus z equals to 570. Now here, money with money. So, right, so $5 were for the adults. So the adults is x, so it's going to give us 5x. Teenager tickets are $3, and teenagers are represented by y, so that's going to give us 3y. And lastly, $2, the tickets for preteens, and the preteens is represented by z, so it's going to be 2z. And what was the total number of people? What was the total number of income? Was 1,150. So this is my setup. 5x plus 3y plus 2z equals to 1,150. So I have equation 1 and I have equation 2. So we're missing equation 3. The second to last sentence is where we find the info for equation 3. Okay? So this is what it should be, right? We know that teenagers is y and preteens is going to be z, right? So this is my setup. This is what that means. 3/4 as many teenagers as preteens attended. So this is what it means. Y equals to 3/4 z. But at times, this is difficult to understand. So if it's difficult and these type of problems, write it how it sounds and then move the coefficient to the other variable. What am I trying to say here? Okay, this is what it is. You write it how it sounds. So doesn't it sound like 3/4 teenagers, which is 3/4 y, equals to z, and then you move the coefficient to the other side. You see, guys, there's my setup. But now I want to put it in that form, right? I don't want no fractions. So I'm going to multiply both sides by 4 to get rid of the fractions. So 4y equals to 3z. Now I'm going to subtract 3z to both sides. So I have 4y minus 3z equals to 0. So that's my third equation, I'm sorry. So we have the 3 equations. Now on the next slide, we're going to solve it. Okay? Let's try it. So these are supposed to be my solutions. Okay, so let's do it. So there we go. Okay, I'm going to use, remember the setup? I'm going to use equations 1 and 2 to get rid of the x's. So I'm going to multiply equation 1 by -5. Why? Because -5 times x will give us -5x. Then when I add them, they'll be eliminated. But I need to multiply -5 times every term. So once we do that, equation 2, we just write it down. So we have negative 2y minus 3z equals to negative 900. So that's my new equation 2. If we notice, equation 3, there's no x, so we don't have to do that step no more. So this is like my new equation 3. Right? Now I'm going to get rid of the y, so I'm going to multiply equation 2 by 2, because 2 times negative 2 will give us negative 4. Then when you add it to 4, they'll cancel, or they'll be eliminated. Okay? So it's going to give us negative 9z equals to negative 1800. We divide by negative 9. Both sides, so we get z equals to 200. Now, right? Now I get to back substitute. So I'm going to go to equation 2. I'm going to plug in 200 for z, and then simplify, right? So this will give us negative 2y minus 600 equals to negative 900. So I'm going to add 600 to both sides. So it should give us negative 2y equals to negative 300. We divide both sides by negative 2, and we get y equals to 150. So I got the values for z and for y. Now I'm going to plug those values in for equation 1. So y is 150, z is 200, right? We combine those two terms, so it's going to give us x plus 350 equals to 570. We subtract 350 to both sides, and we get 220, right? So we have 220 adults, 150 teenagers, and 200 preteens. And this is how you work these type of problems. There's much more material to be covered, guys, but I can only do enough for 1 hour. Okay, I hope you like this PowerPoint, and we're done. So let me go back and see if you guys have any questions.
No questions, so, Mr. Azasi.
Okay, thank you, Patricia. So
thank you, Mr. Azasi.
Oh, you're welcome, and thank you for being patient, and thank you for waiting we went over like 15 minutes, but thank you.
It was worth it. Thank you so much, Mr. Azasi.
You're welcome. Bye-bye, guys. Thank you. Bye-bye.
Before I let you go, I would like to invite you all to next week's session. For Math 1314, we'll be going over exponential and logarithmic functions as well as their properties. For Math 1324, we'll be going over, whoops, that was today. I'm so sorry. For Math 1314, we'll be going over matrix operations and inverses of matrices, as well as their determinants. And then for Math 1324, we'll be going over sets, probability, permutation, and combinations. Hope you all have a wonderful weekend. Have a good day.
Bye-bye.